So for the calcium, I got a question about the calcification. So if you really exclude all the calcium sometime, what that does, let me just show you here, that will really exaggerate. Like, let me just show you. So you see how this here, if I just go this way, and let me just move this away. And if I go this way, and I go this way, you know what that does? It will increase your parameter, because now you're kind of like a funky, like, contouring. So it tends to increase the parameter. So when you size your evolute, the self-expandable valve, now you are kind of getting a bigger size valve. So you don't want to do that. So try to, dive in the calcium as we did before. So if I may have your attention just for like another minute or so for this case. So let's just pay attention here. So now there are a few things we look at after the annulus. When they put the valve, they're going to go into the LVOT. So there are things in the LVOT we pay attention to. One is the sizing. Does the LVOT funnels down so much? So imagine this is your TAVR. And if the LVOT is so small, by the time you put the TAVR in a small LVOT, it might injure the LVOT. So if the LVOT area is really small, we'll talk about how we measure it. If there's heavy calcification below the annulus into the LVOT that goes 3-4 millimeter or more, that's also another high-risk features. So how do we measure the LVOT? There's a simple way, honestly, and I've been doing it. You see how the long axis on both the right and left there? Go ahead and activate your distance, D, and go on the pink line is your annulus that is being locked. So go from that pink line on the bottom and just make a distance of 2 to 3 millimeter anywhere. So let's say this is a 2.3, just hypothetically. All right, so from here, you just scroll on your short axis. I'm just going to scroll back and forth and come down to the LVOT. So the audience here, I'm right now at 2 to 3 millimeter below the annulus. What things do you pay attention here you see in the LVOT that you need to pay attention to? Calcification. Where is the calcification? Which cusp is this? Good job. So I would mention there is it can be worse, but there's some nodular calcification below the NCC extending up to 3, even more. Let's go down, maybe 3, 5, even millimeter. You see how it goes down and becomes part of the MAC? So this is something worth paying attention to. So now we go back here. So you see how I know I am about 2.3 millimeter from the annulus. I go ahead again and activate my polygon, Control P, and just measure it, the same thing. Can be better, but just for the time. And you see how I dive a little bit in the calcium. And remember what was the area before for the annulus? What was the area before? 600. So this is 628. So we know the LVOT is not smaller, so that's out of the way. So you just report in the impression that the LVOT area is similar to the annulus area with some calcification below the NCC. And from here, you can measure the dimension the same way, the minimal dimension and the maximum dimension. Remember again, we do not rotate things. So if I want to go back to the annulus from here, I just scroll on my short axis to where I was before. So this is my annulus. Any questions so far? Now we're going to go to the coronary height, how we measure the coronary height with confidence. Questions so far? All right, so now let's see how we measure the coronary height. So try to zoom out a little bit from the annulus just to kind of have better visualization of the long axis. So let's zoom out. So now you see the coronary height. Again, we rotate on the short axis. So I'm just going to rotate on the short axis where I see the coronary arteries coming in and out of the plane. So from here, let's just show the right cusp. You see on the bottom right, that's your RCA coming off. So let's just open it better. So this is my RCA. So what you do, you go ahead with distance and you measure from the ostium. You don't want to be generous, so try to be conservative. So I go ahead and come perpendicular to the annulus. Again, my pink line is my annulus. That's why it's locked. So what's the RCA height here? 11 millimeter. Anything above, honestly, 10, 11, you're done. Typically, when it gets in the lower 9 or 8, then you need to really pay attention to the measurements and really see if this is a low height. So I always measure the RCA height and the sinus at the same time. So this is how I measure the sinus height. So this is the RCC height, and it's about 17 millimeter. So this is for the RCA. Let's go ahead and do it together. The left main. So again, I just rotate and open my left main. So you see how the left main opened up here. Again, like you might say, is that the RCA of the left main? If you scroll back and forth, the letter L should show up on the screen in a hot second. Here we go. So I know with confidence that's my left main. I go ahead with the D and I measure my distance. And the left main here measures 13.7 millimeter. And the sinus height measures about 21.5 millimeter. Any question about the left main height? And the same one, we do the non-coronary height, just the sinus. So if you scroll through the non-coronary height, you can open it in a second. Let's just show you how. So that's my non-con. And from here, I just go ahead and measure the height to 21.9. So this is for the coronary height. Any questions so far? We're going to talk about the aortic root angulation.